All right, folks, so this is going to be the last video for the additional exercises, and this is going to be the last video for the relational ones. Everything else right now that I'm going to put up after this is only going to be for stuff from Lemon. Though I would say for your homework, if you haven't been paying attention to the way that things are done in these or the way that things are done in Lemon, you're going to lose a lot of points. A lot of this stuff is stuff that you should be noticing that is happening, so please pay careful attention. Specifically, pay careful attention to how the key is made. This is how you should be writing your key. If you don't write your key this way, you're not doing something right. That said, let's get started. In this one, we see that everything has a cause. So everything is going to be all x, it's universal, has a cause. So this is going to be y causes x. And a cause means that there's going to exist some y of some sort. And then we have this statement, but this means an ampersand. So this is going to be one clause, and then we're going to have a second clause. For all x and y, if x precedes y, then y does not cause x. So for all x and all y, if x precedes y, then it's not the case that y causes x. So we have all the pieces here. Now what we need to do is go through and put them all together. So let's start with everything has a cause. For all of x, there exists some y such that y causes x. And for all of x and all of y, if it is the case that x precedes y, then it is not the case that y causes x. Let's go on to 13. Every entity is either necessary or dependent on a necessary entity. So every entity, all x, is either necessary in x or it's dependent on a necessary entity, or there exists some y such that y is necessary and x is dependent on y. So for all of x, if x is either a necessary entity or there exists some y that is a necessary entity and x depends on y. So this is a little bit odd because here we have a wedge instead of an arrow, but this is going to be one of the cases that every once in a while we will have something with a universal quantifier that is not an arrow. Let's go on to 14. No logician, so it is not the case that there exists an x. Logician is Lx, and then argues is going to be A, X, Y, Z. Argues about every subject. So for every subject here, there's going to be all of y. It's going to be y as a subject. And then we have everyone. This is going to be all z. And we know that z is a person. So one of the translations, and there's two here, it is not the case that there exists an x such that x is a logician and for all y, if y is a subject, then for all of z, if z is a person, that x argues about y with z. An alternative translation would be, for all of x, if x is a logician, then it's not the case. For all of y, s, y, arrow, z, p, z, arrow, a, x, y, z. Let's go on to 15. Either nothing is dependent on anything or everything is dependent on something. So we're going to see that we have two clauses here. So we have a disjunct. There's clause 2. Here is clause 1. Nothing is dependent on anything. So let's start with there. Nothing. It is not the case that there exists an x such that anything, could also just be in this case, exists y, and dxy, x depends on y. Or everything, all of x, we have a something, exists y, dxy. So for the first part, nothing is dependent on anything. It's not the case that there exists an x such that for some y, x depends on y. Or for all of x, there exists some y such that x does depend on y. A quick note about this one, this is also equivalent to saying x negation ey dxy, or even all of x, all of y, not dxy. These are also equivalent to negation existential x, existential y, dxy. Let's go on to 16. No one is obligated to everyone. So we have no one. So this can either be not the case that there exists an x, or it could be a universal, and then down the road we have a negation. Obligated, oxy, to everyone. And this one's just going to be a y, knowing that y is also a person. So we could translate it. Let's do the existential first. It's not the case that there exists an x such that x is a person, and for all of y, if y is a person, that x is obligated to y. Or with the universal, for all of x, if x is a person, then it's not the case for all of y. Py arrow oxy. So let's go on to the second page. In this case, it's going to be the last page. Everyone is obligated to someone. So everyone, all of x, oxy, someone, there exists a y. We also want to clarify that everyone, we're talking about people here, someone, talking about a person. So for all of x, if x is a person, then there exists some y such that y is a person and x is obligated to y. Or we could say that it's not the case that there exists an x such that x is a person and there's not someone that is a person to whom x is obligated to. Both of those would work. Some number is greater than itself. Some number, there exists some x such that x is a number. Greater is gxy, and then itself, we know we're going to have the reduplication of the same letter. So there exists some x such that x is a number and x is greater than itself. Voldemort hates all muggles. Voldemort, little v, hates, x hates y, all muggles, y and y. So for all of y, if y is a muggle, then it follows that Voldemort hates y. You could also say it's not the case that there exists, we can use x too, there exists an x such that x is a muggle and not hated by Voldemort. Now we get into the longer ones. Some philosopher studies every book with some teacher. So some, there exists some type of x, such that x is a philosopher. Studies is s, x, y, z. Every book is going to be studies y part, all y, and we know that y is a book, with some z. So there exists some z such that z is a teacher. So put in this to logic ease, there exists some x such that x is a philosopher, and for all y, if y is a book, then there exists some z such that z is a teacher, and X studies Y with Z. Let's look at 21. Every philosopher studies some book with every teacher. Every philosopher, for all of X, if X is a philosopher, studies SXYZ, some book, there exists some Y, such that Y is a book, and with every teacher. So all of X, or actually let's make that a Z, all of Z, with Z being a teacher. Every philosopher, for all of X, if X is a philosopher, then there exists some Y, such that Y is a book, and for all of Z, if Z is a teacher, then X studies Y with Z. So this is fairly similar to what we did up here, but notice what happens when we switched this operator from an existential to a universal. Likewise, see what happens when we switched this universal to an existential, this existential to a universal. Namely, the signs changed. What we ended up seeing is these things flipped from arrows to and statements, or from and statements to arrows. Let's go on to 22 as another contrast. No philosopher. So you can either do X and then down the road have a negation, or it's not the case that there exists an X such that. Philosopher, PX, SXYZ, X studies Y with Z, any book. So for any book, this can be an existential Y with a BY with any teacher. So this can also be an existential Z and a TZ. So let me diagram this one out. For all of X, I'm going to do all of X first. For all of X, if X is a philosopher, then it's not the case that there exists some Y such that Y is a book and that there is some Z such that Z is a teacher and X studies Y with Z. In contrast, if we put it's not the case that there exists an X, it's not the case that there exists an X such that X is a philosopher and there is some Y such that Y is both a book and for some Z, Z is a teacher and X studies Y with Z. So this is the last video of the optional extra exercises. So the next one I'm going to do is I'm going to walk through the exercises from Lemon.